Hi everyone, in this tutorial we will simulate 3-point bending test of composite material using Abaqus. We will use laminate in type of material composite, and also we will use Hashin failure criteria to simulate the composite failure. We are going to do all necessary steps and tips for successful job. Let's get started. Let's start first with creating of our composite specimen with shell property. Let's create part composite and 3D deformable solid extrusion, or we need to create shell planar. Continue, and we need to create our specimen with sketch of rectangular first with dimensions with 150 millimeter in the width, in the length, and 20 millimeter in the width. Click done. Now we have our specimen for 3-point bending test. Let's add some partition in our part using sketch option. Let's select the part and select the edge in the right. Now we create sketch where we need to add partition in the middle and in this side. Let's add dimensions 20 millimeter and also side, and this line is in the middle of our specimen. Click on. Now we have partitions in our specimen. Now let's create pins for loading and supporting part with 3D discrete rigid and solid element extrusion. Continue. Let's add dimension of our pins. Radius 5 millimeter in the radius. Click OK. Click done, and add 20 millimeter in the depth of our part. Click done. Now we have rigid part of our pin. Let's create reference point, and also we should to convert this part from solid to hollow part with shell. Now we have solid part. Let's create shell from this part. Click in this option, create shell from solid, select part, click done. Now we have hollow part. Let's go to property module and import our material. We don't have any material in our library of model. Let's go double click on it, and we have this material from library to our model. Let's edit this material. We have Hashin failure damage property and elastic property of our specimen with lamina type and Hashin damage evolution with energy type, and also we have damage stabilization parameters. Click OK. Click OK. Now we need to create layout composite. Create name composite layout, and initial count of play equal to 4. You can add any number of play you need. Conversion shell, because we have shell type of our specimen. we don't have. This is shell type, not solid type. If you have a solid type, you can use conventional shell or for layer. Continue, and let's select the region where we need to put these layers. Right click, edit region, select the wall part, click done, and material, edit material, select this material, click OK, and thicknesses, edit thicknesses, 0.25 millimeter, OK, and rotation angle 0 degrees, 45 degrees, minus 45 degrees, and 90 degrees. Let's 1, click OK, and OK. Now let's see our stacking of our composite specimen. Click query information, play stack plot, and select cell. Now we have this plot of our stacking. This is the first layer, second, the third, and the fourth layer. 0 degree, 45, minus 45, and 90 degree. Now let's remove this viewport, and now we need to go to assembly module and assembly our part. Create instance, select these two parts, apply, and select other pin, apply, and the third pin, apply. Now let's make some rotations and movement in our parts. Let's rotate this specimen composite in this axis with 90 degree. Now we have the right angle of our specimens. Click OK. Let's move this part, done, from this point to this point, right position of our supporting pin, first supporting pin, click OK. The second supporting pin, click part, select this first point, starting point, and ending point, click OK. Now let's go to the third loading pin, click starting point and ending point. OK. We have the right assembly of our model. Click done. Now let's go to step analysis and create static general step. Continue. Click and enable on for nonlinear geometry option and dissipation energy, and we need to add some value and size agreement. Okay, and now let's go in file output, edit, and go to failure fracture for enable some property for damage composite. Let's go also to hashing damage property and go to also to status, click OK. Now let's create set point for getting the force displacement curve. You select this point in the loading pin, click done, and let's go to file history output, click edit, select set force displacement, and select which data we need to get in this set. We need to get the displacement in the y direction and the reaction force in also in the y direction. Let's go to this data, and also let's remove energy, and also need to get reaction force in the second direction. We need to get the displacement and the reaction force in this direction. Okay, now let's go to interaction and create property in interaction. Create interaction property 1, continue, and create tangential behavior and normal behavior. Let's edit tangential behavior and add friction coefficient 0.3 and normal behavior with hard contacts. Click OK. Now let's find contact pair automatically with this option. Click on it. Let's click find contact pair. Now we have 3 zones of contact. The first one is this contact. The second one, the third one. Click OK. We have property of contact interaction property 1 that will we created before. Click OK. Now we have 3 contacts. We can edit this contact in this part by edit, and you can reverse between surfaces of contact. Click OK. Now let's go to load. Now we need to go to boundary condition and create our boundary condition. Click initial step, boundary condition 1, symmetry and anti-symmetry and on cursor. Click continue, select the first reference point, the second reference point, and click select the second reference point. Click done, and on cursor click OK. And also we need to create the second boundary condition. Click continue, select a reference point in the loading pin, and select this direction and rotation of movement. Click OK. And now we need to add the displacement in the step 1 in y direction. Let's click reference point of the loading pin, click OK, and add displacement in y direction. Click OK. Now we have our boundary condition in our model. Let's go to mesh, click part, size of elements 1 millimeter, click apply, OK, meshing the part, click done. Now let's go to pin, size 1 millimeter, apply, OK, mesh, OK. Yes, now we have the right meshing of our model. I think we do all necessary jobs in this simulation. Let's go to creating job, create job, and test, composite, continue, and click OK. Let's check the model, data check. These take time for checking our model. If we have any errors, completed. Let's continue our job. Click. We have aborted job, and let's go to the result. We have a wrong result and a wrong animation of our model. Let's go to interaction module, and let's edit our contact and our interaction zone. Edit. Let's edit the surface of contact in the specimen composite side. Let's edit. Let's select surface. Let's select these two surfaces. Click done, and let's select the brown surface, not the purple surface. We have wrong brown surface and purple surface. Should select the brown surface, click brown, and click OK. Now we have contact. Let's go to the second contact, edit. Let's edit this surface. Click, select surface, select this cell and this cell face. Click done, and select the brown side of specimen. Click OK. OK. Let's do the same steps for loading bin and specimen. Edit, edit surface, secondary surface. Click surface. Select this cell and this. Click done, and let's now select the purple side for specimen. Let's click OK. Now let's go to our job and create second job. Let's name it correct instruction. Okay, continue. Click OK, and let's check our model. Submitted our checking. Completed. Let's continue. Continue. OK. Now we have completed job. Let's go to the result. And plot deformed shape, and also plot contours. Let's plot mice stress in wall specimen. Let's go to plot result in each layer in our specimen. File output, select point. Let's select play. Let's select the first layer and apply, apply, apply. Let's change damage, apply, traction, apply, or select Hashin failure criteria. We have this data contour in our first layer. Now we have a wrong selection. Let's select point, play, select first layer, apply, okay. Now we have this contour in first layer. Let's select in the second layer, apply, okay, apply. No, we still have the first layer, okay, apply, okay, result, file output, select point, select third layer, and also click apply, fourth layer, apply. The data changed in the fourth layer, but in the third layer, apply, can't change it. I don't know why this happened. Apply, but the fourth layer happened. Apply, first layer, second layer, fourth layer, okay. Now let's go to extract the reaction force and displacement curve. Force displacement curve, select these two data, click plot, save as is, click OK. We have these data of force displacement. Let's operate this data for plotting the force displacement curve, reaction displacement, reaction force, and reverse the curve, plot, cancel. Now we have the force displacement curve of our specimen. I hope you enjoy with this video. If you have any problem or any question, don't make a comment in this video, and don't forget to subscribe in my YouTube channel and like this video. See you in the next video.